Okay, Chapter 1, Section 6, some rules for differentiation. So these three things are rules that we've worked with before, but we're just going to reiterate them. So the first one is the power rule. So it basically says if we have a function f of x with a power, then we bring that power down and subtract 1 from the exponent. So say you had the example f of x equals x to the 7th. So again, note the notation. F prime of x equals, we're going to bring the 7 down in front, and then we subtract 1 from the exponent. All right, so the constant multiple rule is still part of kind of the power rule, but it's just reiterating what to do if we have a constant in front. So it's really important to be able to read this notation, the d over dx. So it's pretty much saying that I can take this constant out in front, and then I just want to take the derivative of the second piece, okay? And then we just finish the operations as given. So if I gave you the example, g of x equals 5x to the third, we can rewrite it as saying we're going to pull 5 in front and then take the derivative with respect to x of x to the third. So we know that this is going to equal 5 times the power rule, 3x to the second. So we can say that this equals 15x to the second. So you also could have said g prime of x equals 15x to the second. All right, and then the sum rule says that if we have two sums, we just take the derivative of each part. So again, it's important to know that this d over dx implies take the derivative of. It's considered an operation. So if I said f of x equals x to the 7th, and g of x still equals that 5x to the third, then f prime of x plus g prime of x equals 7x to the 6th plus 15x to the 2nd. Again, we know these rules. However, the next one is brand new. So this is called the chain rule. It is very important to understand the chain rule because it is not going to go away. So if we read this notation, what we are pretty much saying is when we have a function inside of another function, then we do the power rule with the outside function, we leave the inside one the same, and then we take the derivative of that inside, and then we take those two parts and we multiply them. All right, so let's look at an example. So if I want the derivative with respect to x of 7x to the 4th. All right, so we're going to do the power rule on the outside. So 4, and then we subtract 1 to the 3. Now the inside stays the inside, and I'm going to try to denote that with a different color here. It stays 7x. Then we multiply by the derivative of the inside. So if we did the power rule with 7x, we would just be left with 7. And then we're going to simplify this and say 28, 7x to the third. Oh, I'm sorry, 7x quantity to the third. Now, I'm going to stop right here for now just to get the hang of the chain rule, but we will begin to simplify even further the chain rule, okay? So we will get to the point where we take that 28 times 7x to the third, and we will simplify it. All right, so let me give you another example. So let's change colors here. If f of x equals 3x squared plus 5x, and we're going to take this to the, actually, let's put this over 1, or under 1. All right, so what we're going to do now, just like we did before with the power rule, anytime you have a denominator, we're going to bring it up to the top. And I'm going to say, okay, well, wait a second. Before I do that, I'm going to use negative exponents. So my new f of x, and still, it's still called f of x, this whole thing now equals 3x squared plus 5x to the negative 1. Now I want to consider doing the derivative and differentiate this, but I need to use the chain rule. So the first thing I'm going to do is drop the negative down in front, and I leave the inside the same. Okay, and then that negative 1 becomes negative 2 because we subtract 1. Now we're going to multiply the derivative of the inside. And here, we're also going to apply the sum rule because we just take the derivative of both parts. So we get 6x plus 5. And that is our final answer. So we're going to practice with this a lot more, but this is basically the chain rule. Again, just to reiterate, we have, I'll use some different colors here. So we have this function, this negative 1 function, shows itself right here. Okay? And then we take the inside. This function on the inside stays on the inside, and then we differentiate the inside. Maybe that helps kind of explain it a little bit. All right, and then just some things to keep in mind. Derivative as a rate of change. Remember, two important properties of the tangent line to a graph at a point A. The tangent line at the point has a slope of the first derivative of that value A. So basically you find the derivative and then you evaluate that function, that new function, in terms of A. And the slope of the tangent line at the point is the slope that best approximates the slope of the original function at the point. So the slope of the tangent line at that point is the best approximate to the slope of the original function, again, at that point. If the function in question is a line, then the slope represents the rate of change of the linear function. If the function is not linear, the first derivative can still be interpreted as a rate of change of the function. And here we have it kind of broken down right here.